Okay, so 7.5, number 5 reads this way. Put into standard form that thing. Okay, so I'm just adding, right?
Yeah.
Are there parentheses necessary?
No.
No. Right? Addition doesn't care. So I just write, all right, this stuff is 1 plus 2i plus 8 minus 3i. And then what do I do?
1 plus 8 and then 2i minus 3i.
So it's negative.
Yeah, group like terms, right? So if I group like terms, I get 1 plus 8 plus 2i minus 3i, which is
9 plus negative I.
9 minus I, or 9 plus negative I, sure.
Oh, so
I'm going to go with 9 minus I, but
Wait.
So you just want a group.
yeah, all you do is regroup.
Oh.
All this is combine like terms.
Wait, so is that the form A plus BI?
Yeah.
Oh.
Oh, if I wanted an sorry, you're right. If I wanted an actual A plus BI form, I would write this.
Oh, okay.
Then the A is 9, and the B is negative 1.
Would it be wrong if we just put 9
Yeah.
minus I?
If you ask anybody who works in the field, yeah, 9 minus I is perfectly fine standard form. But they're also used to reading the A as negative 1 in that case. Or sorry, the B is negative 1 in that case. Yeah.
I have another question in the same section.
Okay.
70 is problem 77.
Okay.
And it's x squared minus 10x plus 26 equals 0. And it says, calculate the discriminant of each quadratic equation and determine the nature of the solutions of this equation. Do not solve the equation. So I was kind of confused.
Okay, so calculate the discriminant and explain nature of solutions.
But we're not supposed to solve it.
Yeah, don't solve it. Okay, so I could solve this, right? What would I use to solve this?
The quadratic.
Yeah, increment the quadratic formula or complete the square, either way. This one, I suppose, would be okay to complete the square, right? Leading coefficient's already 1. This thing's divisible by 2. Maybe that would be fine, right? Okay. If we did do the quadratic formula, how do I know? Wait.
What's that last word?
Solution.
Okay.
So I'm supposed to just do what they said, though, right? Calculate the discriminant. What's the discriminant?
That's the square root b squared minus 4ac.
So the discriminant is that without the square root. The discriminant is just b
What's in the
squared
square root?
minus 4ac.
Oh.
What did she say originally?
She said it was the square root of that stuff.
Okay.
That makes sense? That's the part I need for the quadratic formula. But this one's going to tell me enough. So let's see why. So what are A, B, and C for this one?
110.
Okay, so I get A is 1, B is negative 10, C is 26. Okay, so the discriminant, right, is, let's see, B squared is negative 10 squared, right, minus 4 times
Times
26. Where'd your A go?
There, it's just 1.
It's 1, so it doesn't matter. Okay, so I get 100 minus 104. So this is negative 4. Okay? Now, what I need to think to myself is, okay, what am I doing with this in the quadratic formula? This is the thing under the square root bar, right? So if this is negative, I get complex numbers, right? You guys see that? If I take the square root of negative 4, I get 2i, right? Complex numbers. So this tells me that there are, so since discriminant, so it's going to be the discriminant, is less than 0, there are 2 complex solutions. Cool with that? You guys want to, what are the other options? Yeah. So if the discriminant were 0, there would be something solution, maybe? If the discriminant were greater than 0, there would be some solutions. What goes in the blanks? So remember how this thing gets used, right? There's negative b plus or minus the square root of the discriminant divided by 2a, right? Really, these are my solutions x, right? If the discriminant's positive, how many solutions are there? 2, and what kind of solution are they? Yeah, usually they're positive, negative, but not necessarily. They're real at least, right? 2 real solutions, right? Because I'm just adding negative b plus or minus the square root of something that I can calculate, right? It's not complex. I didn't have to do this kind of crazy I thing. It was just kind of a number that I was used to. What if it was 0? There's fake solutions. No, that's when it's negative, right? When it's negative, there's 2 complex solutions because I got i's in here. When it's 0, what's the square root of 0? 0. What's negative b plus or minus 0? Still negative b, right? So there's only one solution then. So there would be one real solution. Does that make sense? Remember, those are the 3 cases. In this case, I have a parabola that doesn't touch the x-axis, right? In this case, I have the parabola that touches at one point, right, where the vertex is on the x-axis. And in this case, I have the parabola that kind of does the usual, or at least what I think of as the usual thing. Okay, see that? So these all go together, right? There aren't any spots crossing the x-axis. There's one spot on the x-axis. There's 2 spots on the x-axis. Cool with that? That helps, CJ?
Yes.
Other things? What's that?
Thank you.
Sure.